morning, everyone. How's everybody doing today? All 60 of you out there in television land. Hopefully everything's going well. For those of you who are within the sort of greater Golden Horseshoe area of southern Ontario, you are looking at quite the blizzard at the present point in time. Probably looking like I'm gonna have to do some slow shoveling this afternoon, which is just fine. I could use the exercise. Yep. I don't know. Maybe I should start every lecture with a weather report. Of course, in my case, weather report constitutes looking out of my window and seeing what the weather is like out of my window. Maybe I should have like a thermometer right there. Anyway. Hello, everyone. We're going to do some more coding and stuff today. Continuing on in the theme of learning introductory programming in this introductory programming class. Doop-a-doop-a-doop. Here we go. So, last time, we had just sort of gotten into the idea of what a variable is. And, of course, a traditional sort of tripping point for people with respect to programming is the concept of the variable. Variables operate differently in a programming context than they do in a algebraic context. An algebraic variable is a very specific kind of thing, right? It's, an algebraic variable is to say, I don't know what the value of this thing is, so I'm going to say it's variable. Within the context of programming, you don't have the same concept of not knowing what a variable is. It's more like being able to deal with data symbolically. So rather than this algebraic concept that a variable could be anything and we have to find out what it is, variables within computer programs always have a concrete value. There is always a concrete value to a variable, even if that variable hasn't been used yet and has merely been declared. The process of declaring a variable is to say, I'm going to take this segment in my memory, I'm going to call it this variable name within the context of this program, and even if you haven't used that segment of memory yet, the mere act of setting it aside will give it some implicit value. You would see this if you were programming in a lower level language like C. When you declare a variable without initializing a variable in a programming language like C, it just has whatever the particular arrangements of bits in memory were before you labeled that piece of memory as the variable. So it sort of holds over whatever the previous values were that were stored in memory. And of course, the manner in which variables get stored into memory is sufficiently random that the data that is sort of there by default is considered junk or garbage data and doesn't really pertain to anything. No useful thing can be derived from it, so it's junk. It's garbage. So in Python, you have this idea of implicit declaration of variables. So the first time that a variable is used, Python automatically declares it. So if I'm opening up my Python interpreter and I declare some variable x, I assign it the value of 8, that automatically in one line not only assigns the concrete value of 8 to the variable x, it also creates the instance of x in memory. And you can see that, so the difference, though, in Python is a variable must be assigned to before it is used. So let's say I had an expression z is equal to x plus y. If I try to use that, I get the following error. Name error. Name y is not defined. So x is defined. We just defined it as being 8. However, the variable y doesn't have a value. Because it doesn't have a value, Python is like, What are you doing to me? This y variable, it doesn't actually have a value. How am I supposed to calculate a concrete value of z if I don't know what all the concrete values are for all of the variables that you're using? So, if you just define y like something like 2, then you can execute that statement without any problem whatsoever. Things must be declared before they are used, and that's a very important rule of variables. Let me see if I have any questions. If you're having technical problems with the assignments and stuff like that, I would appreciate if you would take those questions to your TAs, perhaps your TA office hours. We're sort of, just by the nature of physical reality, we are behind in the lectures, as we always will be. So if you wouldn't mind, this is not the forum for that sort of question. If you are asking questions, please keep them related to the lecture material, and if you can't get justice from the TA during the office hours, you're absolutely welcome to shoot me an email at some later point in time. So, there are rules for variables. Variables are these names that we give variables, formally speaking, within the context of programming language grammars. We call these identifiers. And there are some rules about what can be an identifier and what can't be an identifier. What can you name a variable and what can't you name a variable? Like, for example, we already know about if statements, right? If x is less than y, then z is equal to 3, Z is still 10, so x was not less than y. You can't use the keyword if as a variable name. If you say if is equal to 78, it says syntax error, invalid syntax. This is not, basically, although it is legal from a construction standpoint, like, if it weren't a keyword, it would be a valid identifier. Because it's a keyword, you can't use it as a variable name. So the rules for variable names, the rules for identifiers, is that they may contain uppercase, lowercase letters, digits, and the underscore, but they just, you must not have them start with a digit. So you can't have magic 8 ball is equal to 3. So that's a syntax error. You can, however, have ball 8 is equal to 3. Right? So, yeah. And also, you can use underscores. Hello world is equal to hello world. So that's valid as well. So generally speaking, we have some naming conventions within... there are a couple of different conventions for representing multiple, English words within a variable name. One of them is to underscore separate, but that can become a little bit cumbersome. The other way that's often used is what's called camel case. Camel case is, again, this is like a stylistic thing. It's not actually required. Camel case, you capitalize the first letter of every word except the first one. And that, that's sort of conventional, especially in languages like Haskell. But it's a good convention that you can use in pretty much any language. The one thing that I would caution against is the use of capitalized first identifiers with a capital as the first letter. So in many, many other programming languages, the sort of default by convention, if not by a strict syntactic rule, is that if you have capitalized the first letter of a of an identifier, then it represents a type and not a variable. Variables, generally speaking, are lowercase, and types and classes are, generally speaking, uppercase. It just, again, it's a stylistic thing. It doesn't necessarily matter. Like, what matters is that you do things consistently. But, at any rate. Yeah, so if you want to take a look at what words you're not allowed to use, you can import keyword and take a look at keyword.keywordlist. And these are all of the terms that you are not permitted to use as variable names in Python. Which is fine. Let's see if we have any questions. Cool. So, assignment. We have been using assignment quite a lot. Anywhere you see me using a single equal sign character to do something, that is an assignment operation. So, as I explained yesterday, when you assign something to a variable, you need an expression that can be calculated to some concrete value. So, for example, in the case of z is equal to x plus y, x and y must have concrete values, and the operations that you perform on them must also result in a concrete value. Whatever that concrete value is, that gets stored in the memory cells represented by the variable z. So, that's an assignment operation. We are assigning a value to the variable. It is an instruction, command, or statement to change a value, not a check on whether two values are the same. So, and this is also a difference between algebra and programming. In algebra, even in algebra, the equal sign is not a check to see if both of the sides of an equation are equal. It is an assertion that both sides of an equation are equal. Right? And that's a very different thing. In a programming context, that puts you, doing that sort of thing puts you more in the declarative programming languages or the functional programming languages. In imperative languages, this means assignment. We also have a mechanism for checking to see if two things are the same thing. That is called equality comparison. And the way that you write that in Python is with two equal signs, a double equal sign. So, z is equal to 10. So, is z equal to 9? False. Is z equal to 10? True. Congratulations, you just learned what Boolean values are. So, not to make things too complicated right out of the gate, but we also have the idea of being able to perform multiple assignment operations on the same line. So if we say x comma y is equal to 3 comma 9, x is going to be 3, y is equal to 9. It doesn't, you're not going to at any point be required to use multiple assignments per line, but if you're the kind of person who is meticulous about trying to fit their code into as few lines of code as possible, this is the type of thing that you would do. It's a stylistic thing that can make your code look less messy, hypothetically speaking. There is an interesting thing, though. Let's talk about swap operations. So, it turns out that a very useful operation to be able to perform is to be able to exchange the concrete values of two variables, right? This is often used in sorting algorithms. We're going to talk a little bit about sorting algorithms a little bit later on, but at the moment, let's just say we have x and we have y, and we want the value of y to be in x, and we want the value of x to be in y. how do we go about doing this? Well, the intuitive way of doing this would be to say x is equal to y and y is equal to x. Let's see what the values of x and y are. X is 9, so x does have the value that y used to, and y is 9. So y has preserved its previous value. So what has happened here is the first assignment operation overwrites the value that's contained in x. So that value that we are actually wanting to move into y, it no longer exists. It has been blown out of existence. It has been deleted. Delete. For all you Doctor Who fans out there. So that's a problem, right? So the classical approach to solving this problem is to use what's called a temporary variable. So let's just reset the values of x and y here. So rather than so this is a 3 assignment operation, not a 2 assignment operation. What you want to do is, first of all, you want to assign to the temporary variable whatever the value of x is. Ooh, you know what? This would be a good thing to do in Python Tutor. Let's do this in Python Tutor. Just so you can visualize the way that the memory is working. So, x comma y is equal to 3 comma 9. Temporary variable is equal to the value of x. We then, this means that we've saved what x is. We can then assign into x the value of y, and as the final step, we pull the former value of x not from the variable x itself, but from the temporary variable. So let's visualize the execution. So we initialize both things. We've got in the global frame x and y. You don't have to worry about what the global frame is. Basically, this is just all of the things that have been declared at the top level. At the level of main execution. It's not important until we start talking about scope. So then we assign temp. Temp gets the value of 3, which is what x is. X gets 9, and then y gets 3. And then if if you're in a programming language that cares about such things, you may then proceed to delete the temporary variable because it has served its purpose. So, yes. So there you go. Swapping operations. So in Python, however, one of the things that Python does is it different things do. Like there are certain contexts in which it substitutes what it thinks you mean by a certain operation, or it gives you some way of specifying something that, is sometimes a little bit tricky to pick up that it's doing that if you're new to programming. So if, in fact, in Python, you do x comma y is equal to y comma x, that actually performs the swapping operation and including the temporary variable, because that's the way the computer has to do it, except that it deletes the temporary variable immediately afterwards, so you never actually see what's going on in the background. So if you want to swap two values, you can do it in one line using multiple assignments in one line. It's doing extra work behind the scenes to make that work for you. You'll often hear me talk about, the stuff that Python is doing under the hood. It's really important to understand what Python is doing under the hood, right? Otherwise, it's the difference between you being the master of the tool and the tool being the master of you, right? So let me see if we have any questions. Cyberman, yep. Yep. So, naming variables. Try to use variable names that help you remember what role that object played in your code. I touched on this last time in class. Also, we pronounce a is equal to 4 as a becomes 4 when we remember to do so. So, if we have 3.14159, we might want to name that pi. If we have some other thing that is going to be used in the formula for the area of a circle, we would call that the radius. We would name that something useful. Because, if you write something and then you come back to it later, you don't want to have to reverse engineer what everything was supposed to be. Just name it what it's supposed to be. That way, when you come back, there's no guesswork. There you go. So, let's talk comments. And this sort of feeds into the previous point, because we're now talking about documentation. When we say the word documentation in a programming context, what we mean is, tell us what you did, please. Again, it comes down to that problem of, would you rather reverse engineer your own or someone else's code in order to figure out what the heck is going on, or would you rather they had left you, like, a 6-word sentence in, whatever language it is that you speak, in order to, very quickly indicate the purpose of some segment of code, right? It's far more easy to say that in, a natural language than it is to interpret the purpose from code itself. Especially if you happen to have the misfortune of working with someone who's a bad programmer. Which is, entirely within the realm of possibility. There are tons of terrible coders out there whose code is it's like trying to decipher Egyptian hieroglyphs. You require it's beyond what could be expected of someone to do a degree in archaeology just to be able to interpret the code of one person working on a team. So comment your code. Comment your code. Comment your code. Comment your code. So, okay, fine. I'll comment my code. How? Easy. Use the octothorpe symbol. This is, a lot of people call this the hashtag, but as one of my students pointed out in a previous semester, the actual technical term for this character is octothorpe, which is just so fun a word that I have to use it as often as possible. So, you can add explanatory comments to your source code that won't get executed. I think you can do this here. So it's like, this is not code. And it doesn't execute, because it's not code. This can be a little bit more useful in the context of an actual file, though. Generally speaking, there's no point in putting comments into the interpreter. So what happens with a comment is that the interpreter just skips the line. It just says, okay, that's a comment. I'm not going to, that's obviously not anything that's meant to be executed. I'm just going to ignore the fact of its existence. Comments are specifically and solely for the benefit of the programmer, not the compiler or the interpreter. Winter 1MD3 winter code. So yeah, let's get it to topic1.py. There we go. Right. So, for example, if I wanted to leave a comment, actually there are already some comments here. Octothorpe calculates the median of 3 numbers. Right, so that's a description of what the function does. You can also leave these things inside of lines that already have stuff in them. So, performs a function somehow. You should try not to make your comments too sarcastic. But basically, whenever the interpreter encounters the octothorpe character, it takes the entire rest of the line and it drops it. So, if that character is the first thing in that line, then it drops the whole line because there's nothing before it. But yeah, the other very useful thing you can do with comments is toggle code. So, if you have a piece of code that you don't want to execute for a particular run through of the program, you can comment it out. This is a way of saving the code in the same file as the code should be used without actually specifying it as executing that particular iteration. And if you want in a future iteration of that program to actually use that code, you just uncomment it. You bring it back into existence. That's a really handy thing to know how to do, is to turn instructions on and off using comments. Very, very handy. That's a practical tip. Questions? Should you comment the assignments? So the thing about the assignments is that they're going to be graded by a machine, right? The machine is not going to see your comments. Comments are generally very useful when a human being is checking through your code. In fact, when for example, I sometimes do written tests on paper for this course, just because the information control is much easier if it's a written test. In those sorts of cases, writing out comments can be extremely helpful because it can, generally speaking, when a human is marking your test, things get marked as much for process as for the actual answer, right? Demonstrate that you were, approaching the problem in the correct manner. So in those cases, leaving comments in code that you've written on a test can indicate correct process even if you've messed up the syntax, for example. But because everything is being marked by an autograder here, the autograder is not going to see the comments. So I would advise you use the comments for your own benefit and not the benefit of the person marking it, right? It's just, yeah. And commenting for your own benefit is a good practice. So, yeah. Would it be possible to use the code to uncomment or comment sections of the code? Yeah, that's called macro. Those are called macros. I mean, to some extent, that's also what an if statement does. If you have two branches of an if statement, right? If one, based on the condition of the if statement, one of those branches doesn't get executed, it's functionally equivalent to having been commented out, right? So in some sense, you can do that with if statements. There's also a way of doing it with macros, but macros aren't really a thing we're going to be covering in the course. Are the midterms going to be machine graded like the assignments? Yes. Everything is going to be auto-graded. Everything. However, I have a policy with respect to auto-grading, because people are like, oh man, if all I have available to me here is, robots are going to grade my assignment, we are coming for you, sort of thing. But, so my policy with the assignments and the grading of the assignments is you always, always, always have the option, if you feel that the autograder has dealt with you unfairly, you have the option and you have the right to bring that particular question that you feel you were graded unfairly on to either the TAs or myself, and we will perform a manual evaluation of your grade to see how many marks we think your answer is worth as opposed to the robot. I would, of course, caution that we tend to think that the autograder is pretty good. So, don't, it's kind of like, if you think that you can, if you're thinking, oh, well, I'll just bring every question to people then, and then I'll get more marks in this course. Generally speaking, nope, that's not what's going to happen. Normally, the way that it has to work is your punishment at the hands of the autograder must be disproportionate to the crime of the mistake you made. Because we are necessarily using, what we think is correct is also what the autograder thinks is correct. That is to say, if your assignment question produces the expected outputs for the provided inputs, it is correct. And that is what the autograder tests, right? And generally speaking, because you have the interpreter and the available to you for the purposes of writing the test, we're generally not hugely sympathetic to the submission of solutions that contain syntax errors or don't execute. So please do not imagine that if you submit an assignment solution that is full of syntax errors and can't even be executed, that we're going to have a lot of sympathy. Neither we nor the robots will have much sympathy for you at that point. So, if the code runs properly while you're doing the assignment, doesn't that pretty much mean you're good? Yes. Yeah, so the purposes of us providing test cases for you guys is for you to be able to test your code, right? So, these are a couple of cases where we will give you the input and we will give you what the expected output is, and if your assignment executes these test cases correctly, then you can be reasonably sure that your solution is a good one. Now, there's a big ol' asterisk hanging off the end of that, because we do not, we test different test cases for the test cases that your grade comes from. Those are different from the visible ones, and there's a very good reason for that. Essentially, it would be trivial for anyone to write a program to one or two test cases. You wouldn't even necessarily have to look at the question. All you'd have to do is look at the inputs, look at the output, write something that says, if these inputs then just return that output, and you're done the assignment question. It's trivial to write to one or two or three test cases. So, because you don't actually have the knowledge of what the hidden test cases constitute, that's why you have to base your solution on the problem description rather than the test cases. The test cases are meant to aid you. And, generally speaking, we write for each of these questions, we have a solution that we execute to find what the expected outputs are for the expected inputs, right? So, in those cases, you can be reasonably sure that the test cases are a good pointer in the direction of, do I have a good solution? Just keep in mind that just because you get the visible test cases doesn't mean you get 100% on the question. One of the things that we like to do in the hidden test cases is test what are called edge cases. So, does your algorithm work for, for example, if it's something that's operating on a list, can it handle a list which doesn't actually contain any elements? Will it still return something something that's, in keeping with the question description? But yeah, at the latest Monday, yeah. Yeah, those are good questions. Oh, I had a dip. Did I cut off there for a second? Hopefully I didn't. All right. Okay, so that's comments. So, for example, formula to calculate the area of a rectangle. Width is the length of one side of the rectangle. Height is the length of the other side of the rectangle. There is such a thing as over-commenting, but generally speaking, you should err on the side of more rather than fewer comments. So, let's talk about Booleans. Bool is the abbreviation for Boolean. A bool is another type of scalar object in Python. It only has two possible values, true and false. You have true, you have false. This is logic we're talking about now. There are no intermediate values between true and false. A thing is either true or it is false. You can think of how this relates to circuits by thinking of high and low voltages. True is high, false is low. So, in Python, the Boolean literals are capitalized, so you have false, x is false, y is true. There you go. It is of class bool. That's a data type. We've got various operations which exist with respect to Boolean values. These are all comparator operations. I think I am going to show you quickly the... let's stick to the slides. It'll be there eventually. All right, so you can generate Boolean values based on the values of integers or floating point numbers, for example, by using what are called comparators. These are the comparators. Comparators are operators that compare things. So, let's say I had p is equal to 8, and q is equal to 9, and r is, equal to 8. P is equal to r, true. P is equal to q, false. P is less than q, true. P is less than r, false. P is less than or equal to r, true. So all of your inequality operations that you remember from algebra, they more or less have their equivalents within the context of Boolean algebra. So when you perform an if statement, it expects you to have a Boolean value as like the return result or the final result of the expression that you provide to the if statement. So if p is less than q, do something else, do something else. There you go. Right? Make sense? How are you guys doing with the material? Am I moving too quickly? I'll just I'll take a quick moment. I'll take a quick moment to sort of wait to see if anybody has any questions. If you find everything good so far, give me a thumbs up or something. Good so far? We're still pretty in basic territory, so okay, good. The trick with this type of data is like, or the trick with this type of information, I think, is to try to get it related to algebra, because that's like, I'm assuming that most of you should have a pretty firm foundation in algebra. That's why I'm drawing all of the allusions to algebra that the slides are not. So, very important thing, equality versus assignment. This is a common programming pitfall. If I want to say something like q is equal to 5 and do something based on that, that's one thing. If I say q is equal to 5 with one equal sign, that is invalid syntax. In Python, they'll just barf that back up at you and say, nope, that's wrong. You need to not do that in that context. But, and this is kind of future-proofing you against other programming languages that you may wish to pick up at some point in the future, like, for example, C++ is like this. Inside of it, if you use an assignment operator inside of an if statement, it will actually perform the assignment within that if statement. And then it'll take, like, the return value of the assignment operation, whatever the heck that's supposed to mean, as the thing that it evaluates truth or falsity on. So just be careful. In Python, it's illegal, but it's you can get caught on that in other programming languages. Double equals is equality comparison. Single equals is assignment. There you go. So yeah. It's also important to note that since equality is an operator, it's kind of in the same way that, like, if z is equal to p plus q, z is 17, but the values of both p and q are unaltered by the calculation of that expression, right? In the same way, calculation of the value of the equality expression does not affect the concrete values of any of the things over which it's being operated, right? If you've got p equals q is equal to p, that's false. Q and p remain unaffected by the performance of that operation. Cool. Very good, very good. Good, good, good. So, let's talk about functions. We've already kind of talked about functions a little bit. Functions are one of your primary mechanisms for abstraction. So, the ease of use of a programming language for sort of middling to advanced users is entirely wrapped up in how good the mechanisms of abstraction are. So what do I mean when I say a mechanism of abstraction? What I mean to say is it how can one represent as many statements as possible as quickly as possible, right? So within programming, and this is actually a very old idea within programming, you have the concept of the subroutine, right? A segment of code which can be repeated often. You label that segment of code so that it may be referred to symbolically rather than, copied or pasted into code multiple times. So if you're going along and you're programming and you notice that you're going back up, earlier in your code, highlighting a bunch of it, copying it, and then pasting it down there, you should be using a function. If you do that once, you should be using a function for that instead. So functions they're that aspect, code reuse, combined with the idea of parameterization. So when you parameterize, what you're saying is, I want this code, this sequence of instructions, to execute slightly differently based on some input that I provide to it, right? So, it's not simply just, reusing some segment of instructions, although it can also be used like that. It's also setting up some inputs and specifying some output. So, in computers, we're all about input-output, right? Input, output, input, output. Input, output, and memory. Like, that is input, output, memory, and the CPU. That's your von Neumann architecture, right? If you remember from topic 1. So we have specific mechanisms in order to make a function into a box that takes inputs and produces outputs. We actually refer to these as black boxes. We'll get into this a little bit more when we talk about testing, but once you have taken this code, set it aside, given it a name, specified some sort of, you should you should be able to rely on some sort of, you know, if I give it these inputs, I'll get those outputs, right? Once you've done that, you can actually completely ignore all of the code that has been put into the function. You don't have to worry about how the computer is actually calculating the output from the inputs. All you have to do is, you know, be able to use the function, which is much easier than writing the function. So by doing that, that is how you abstract, that is how you modularize code in order to not have to work with the entirety of the code, the entirety of the set of instructions in a piece of programming, all as one monolithic entity. But anyway, so this is the syntax for how you create a function. You guys, on assignment 1, you should be seeing this already. You should have seen it, like we've seen it a few times in class so far. You use the def keyword. This stands for definition. Definition! Then you provide the name of the function. Names of functions follow the same rules as names of variables. So you're not allowed to start with a number, and you're allowed numbers, letters, and the underscore character. You then have round braces and a list of inputs. For example, in the median function, we have a comma-separated list of variable names delimited by round braces. And then, of course, in Python, this colon character actually indicates the next line should be indented. One more from where it is currently. So, if you'll notice, every time the indentation steps up one notch, the previous line was terminated with a colon. So the colon is required syntax. Don't worry about it. You'll forget it a lot, but the compiler will complain at you that you've forgotten it, so you just go in and fix it. It's very, very important when you're dealing with these types of errors to pay attention to the output that the computer is giving you about the error, because it'll tell you what line that error is on if you're paying attention. And that will, you know, that'll save you having to look through every single line of code for this error that you're not even sure what the error is, which can be very time-consuming. So use the information available to you, please. Anyway, where were we? Boop, boop, boop. So, yes. So you then proceed to have the body of the function, and then at some point, you need to return the return value of the function. So again, going back to this median example, the return statement is right here at the end of the function. We're using a variable m to save intermediate results, or save what the final result should be, and then we run through the body of the function where the value of m is set, and then m is specified as the output for the function. Now, this is not the only way of going about doing this. You can actually save some memory by doing the following. Rather than assigning everything to an intermediate value, whenever any of these things hit, we can just return the values directly without saving them to an intermediate variable. Now, there's a cautionary, you have to be careful when you do this, because what this does slightly is it obfuscates what the entry and exit points to the function are. So it's not as obvious where the function starts. Well, it's always obvious where a function starts, but it's not so obvious where a function ends, right? And it's possible, if you're doing this sort of thing, to write a branch of the program that doesn't have a return statement in it accidentally. And if you do that, then essentially execution will reach the end of the function without having hit a return statement. And in Python, what it does is it returns a null value. The null value is actually called none in Python. So it will return a thing that's not anything that you wanted, presumably. unless returning none is your expected functionality, but it will be only in rare cases. And I don't think a single time in any of the assignments. So, yeah. Return values. The return... I've had a few questions about this. The return statement, it does two things. It says, okay, this is what the output value is, and it immediately terminates execution of the function. When you hit return, it's like, okay, I'm stopping. I've got it. I'm done. I know what I need to return. I'm returning it, and I'm done. And speaking of being done, our lecture's actually done. So, if you have any questions, I'll stick around for a few minutes to answer any questions you might have. But otherwise, we will see each other again on Thursday. So yeah, cool. How do you get a function to return a string? Do you have to write print? No, actually, there's a big difference there. Big O difference. So if I have def returns string, just a function that does nothing except return a string, you return the string you want to return. This deals with the string as a sort of a literal value rather than actually putting. So what print does is it just like shows it. It prints it to standard output, which is, you know, you guys probably don't know what standard output is. It prints it to the terminal, right? Print. It sort of sends the string external to the program, to the operating system, and tells the operating system, please show this to the user. That's what print does. However, if you wish to return a string, make a string, the data inside of a string, the return value of a function, you have to use a return statement still. Returning a string from a function is not the same as printing it. We can print it if it's been returned from a function, though. Oh, there. There you go. Can you have /call a function inside of a function? Yes! Yes, you can. Those are commonly called helper functions. So it's like, for example, def f1 x def f2 y return 3 times y, return f2 of x plus 8, sure. And then if we do f1 of some value 10, you can see that so it takes 10, it calculates f2 on it, which multiplies it by 3, that then takes that as a return value and adds 8 to it, so the return value is 38. However, the interesting thing about that is because we have defined f2 within the context of f1, that actually makes the function f2 local to f1, which means that it's inaccessible outside of f1. You can't actually get at it. It's not formally defined outside of the function in which it's been defined. So it's a way of using it's a way of using functions without cluttering up your namespace. But yeah, hopefully that's an answer to your question. Okay, well, seems like nobody has any more questions, so class is dismissed. I'll see you guys at in 2 days' time. 47 hours into the future. Use those 47 hours wisely. Take her easy, folks. Actually, 46 hours into the future.